In today's video, we're going to look at chapters 9.1 and 9.2, which looks at an introduction to sampling. It's kind of just going off of what we did right at the start of this course, but this is going to lead us on to some other stuff that we're going to do throughout chapter 9 and chapter 10. 9.1 just gives us an introduction to what random sampling actually is. So we know that we use a sample. We did this back in chapter 1. We use a sample because sometimes if we were to try and gather information about a whole population, it's just too expensive and too time consuming, and it's just too much to do. Like, for example, this year when they did the census, trying to do a census of the whole population is incredibly expensive and incredibly time consuming. It takes them the whole year to do it, so they only do it once every 10 years. So instead, what people like to do, instead of just surveying a whole population, they just find a smaller sample that they can then pull information from the people in that sample. Makes it way cheaper, it's way quicker, and then that way we don't have to deal with a whole population. The problem that you have is whenever you pick a sample, you have to make sure it is one thing, and that is representative. Okay, let's say I was taking a survey of our whole class, okay, but it was just too time consuming for me. So instead I decided, okay, instead of asking the whole class a question, I'm just going to pull a certain sample of people from the class and just ask them instead, because it's quicker to do it that way, okay? Now the issue I have, let's say, is if I picked all girls, okay? If I picked, let's say, 5 girls out of the class and said, okay, I'm going to ask you one question. The problem with that is I'm just asking the girls. I'm not even taking into account what the guy's opinion was, okay? I'm just focusing on the girls if I do that. The sample I have taken is not representative. I have only taken a sample of one gender. I haven't considered both of them, okay? So you have to make sure whenever you take a sample from a whole population in order to survey them, in order to find out information about the population from using a sample instead, you have to make sure that sample is representative of the whole population. So I'd have to make sure I had a representative group with both girls and guys. I'd have to make sure I had a representative sample where I've represented all ages, where I've represented all backgrounds, I've represented all races, okay? So you have to make sure whenever you take a sample from a population, in order for you to get decent results out of this that would be close to what you would get if you asked the population, you have to make sure that sample is representative. If you do not have a representative sample, so if the sample is not representative, of the whole population, okay, then we say that the data that we get from that sample is biased, okay? Like I said, if I just wanted to survey our class, but I took a sample of just girls, that would probably make my information that I get from them biased, okay? So if you only pick from a certain group within your whole population, it will probably make your outcomes and your data biased. So that's 2 words that we need to be aware of: representative and biased. If we don't have a representative sample, it will make the data that we get from that sample biased. Okay. 2 other things that could cause biased data, okay? It's not just a case of you picking a particular group to be your sample, for example, where I said I've just taken girls as my sample from a whole group of girls and guys, okay? That would make it biased. The other 2 types of sample or sampling that make you have biased data are voluntary and self-selected. Voluntary samples are where people volunteer to be a part of the sample. Okay, it's like whenever you get emails through, like I get emails through from, let's say, my electricity company, and they want to know, would I like to take part in a survey as to what my experience has been with that particular company? Have I liked the service that I've gotten from that company, etc. Okay, I can volunteer to answer their survey and to go through all the questions. Okay, not many people have time to do all of that, okay? But you tend to have a particular group of people that maybe have more time on their hands in order to answer it, or maybe you end up with the people only answer it if they have something serious to say. So you will end up with biased data because the people that really want to tell you their opinion on these surveys have either had a really good experience with you or a really bad experience with you. So it's going to cause biased data. Okay, so voluntary samples tend to cause biased data, and also self-selected samples. Okay, again, same type of thing. You self-select to be a part of the sample. Okay, so both of those are going to cause biased data. In order to actually get a decent sample, okay, we've said that the problem that we have is we need to make sure it's representative of the whole population. Okay, so the difficult part about all of this, whenever you're trying to find a sample for your population in order to give you good data that would represent what is actually going on in the population, the biggest hurdle to actually get over is to make sure that you have a decent sample in the first place. So what we tend to do is we get something called a sampling frame. And a sampling frame is just a list of everyone in the population. So once we have this list of everyone in the population, we could say, okay, I'm going to randomly select people, not knowing what background they're from, maybe not even knowing what gender they are. Okay, they may just number a bunch of people and you can just say, okay, I pick numbers 2, 5, 10, etc. So you have no idea what gender, background, or anything that they are from. And from that, you will get something called a simple random sample. So that is where we have completely randomly selected people, okay? Back in the day before we had calculators and computers and all of that, they actually used these random number tables, okay? And these random number tables would allow you to just, like on the table, it would have random numbers listed and you could say, okay, here is my list of people. I'm going to number them 1 through, let's say, 100. And using these tables, you could pick off random numbers and therefore random people, and you would therefore have a representative sample because you have no idea who these people are. You have no idea, maybe when you pick them, what their name even is. Okay, so you would have no idea about anything about them, but it would allow you to randomly select people by numbering them and then using these random number tables to select them. However, now that we have computers and calculators, we can use these random number generators. Your TI-84 calculator actually has a random number generator on it. And by using that, we can just call a random number to our calculator screen, and then we could pick the person that is attached to that number as one of the people in our sample. So now we use these random number generators in order to select people, in order to create this completely simple random sample. Okay, so we would have a completely random set of people, and it's more likely to be representative of our whole population, and we don't have a danger of, let's say, just picking women, just picking men, just picking people from a particular socio-economic background so that it wouldn't be representative of our whole population. Okay. There is a good video on simple random sampling in one of our Against All Odds videos, and I will attach that on our Against All Odds videos tab on Blackboard if you want to go ahead and watch that, and it gives you some good real world examples of this simple random sampling. The next thing I want to look at is 9.2. And this is kind of the introduction of where we're going to be going through the rest of chapter 9 and chapter 10. And what this is sampling distributions. And I'm going to introduce to you an idea that, I mean, we've talked about this before, but really solidifying that idea so that we can go ahead and use this throughout the rest of our semester and the rest of statistics. Once we have a representative sample, okay, so we've done all the stuff that we talked about in 9.1, we've selected a completely random sample. We've got a random sample within our whole population. So now we can go ahead and use that random sample of people in order to tell us stuff about the whole population. Okay, that's the whole point of taking a sample. We don't want to survey the whole population. So instead, we just want to survey this sample of people. And then whatever data we find out about that sample, we can use that to infer things about our whole population. Okay, that's why we take a sample. It's just quicker and easier, and it's cheaper than trying to find out this information from the whole population. So once we have this, what we tend to do is we estimate some of our population parameters by using a sample statistic. That's the main thing that you need to take away from this. Okay. Remember, a population parameter is just a fact about our population, whether it be the population mean, the population variance, the population standard deviation, the population median, etc. Okay? The sample statistics are the facts about the sample that we have taken from the population. So we've started out with the population, we've taken a sample, and we've found out statistics about that sample. So we found out the sample mean, the sample variance, the sample standard deviation, etc. If you have a completely random sample that is representative of your whole population, we can say, okay, I'm going to use my sample mean to estimate what my population mean would be. Okay, that makes sense because that's the point of taking a completely representative random sample. Okay, because then I can use that mean that I have from my sample to estimate what the mean of my population would be without having to survey the whole population. So, for example, we can estimate the population mean, which we call mu, by the sample mean, which we called x bar. Okay, so for a particular population, if I want to estimate the population mean, I can just take a random sample of people that is representative of the whole population and find the mean of that particular thing for that sample. And then I can use that sample mean to estimate my population mean. Okay. Another one is the variance. So we can estimate the population variance by the sample variance. Okay, same thing. Rather than trying to find the variance of my whole population, I just take a sample from my population that is representative, and then I can find out the variance of that sample and use that to estimate my population variance. And of course, if we can do that for the variance, we can do that for the standard deviation. So I can estimate my population standard deviation by my sample standard deviation. We actually have a name for these sample statistics that we're using here. So for each one of these, and for any other sample statistic that we can use to estimate a population parameter, we actually have a name for it. And the name that we use is actually a point estimator. A point estimator is just a single valued estimate, for example, the mean or the standard deviation or the variance, etc., that can be used from a sample to estimate the same quantity or the same value in the population. So it's a single valued estimate calculated from the sample data, which can then be used to estimate the true population value, okay? We assume that they're going to be very close together when you have a representative sample from your whole population. So it's just a single valued estimate that is calculated in the sample that is intended to be close to the true population value. So, for example, the sample mean, that is a point estimator because it's a single valued estimate. Okay, the mean is just a single value that we can take from the sample, and it should be, with a representative sample, very close to the population mean. Okay, so we can use that sample mean as a point estimator, as a single valued estimator, to then estimate what is going on for your population mean, because those two values should be very close together when you have taken a representative sample. So we can use our sample mean to estimate our population mean. The same would go with both the variance and the standard deviation. Okay, that is all there is to 9.1 and 9.2. It's more of some theory before we get into some calculation stuff coming into 9.3. So make sure you are happy with these definitions. If you have any questions, let me know, and I will see you in the next video.